What's up guys, welcome back to another video. This is a reaction to the insane engineering of the F-35B. I've never done a reaction to this specific plane, but I know it's in a lot of videos that I've seen, a lot of reactions it's involved. It just pops up here and there. And I don't know much about it. I've done the insane engineering of two different aircrafts before, but I've done them quite a long time ago. And I think I also done a reaction to like one of the weapons, a missile launcher or something. I can't remember, but it was a long time ago. But yeah, the videos to this channel, the reactions to this channel were always really interesting because it was just well put together and you see the in-depth details about the specific thing that the video is about. But yeah, the F-35B, I don't know anything about this. It looks like a crazy aircraft, but I don't know what the sort of what it can do. I just assume it's fast. That's its main, the main positive to it. It just looks very aerodynamic. So I'm assuming it goes crazy quick and yeah, probably doesn't get detected easily because it's so fast. But yeah, we're going to check this out, hopefully going to enjoy. If you want to see some more of my military reactions at around the last 10-20 seconds of this reaction that you're watching now, so if you want you can skip to it and watch other of my reactions, or you can wait to the end of the video. You can see a playlist set up of all my reactions to military based stuff, and I don't know if I've put the insane engineering reactions in yet, but if you just search my channel and then the insane engineering, you'll see reactions to a few other videos from this channel. But yeah, that's for those who care for that. If you want to see some more of my reactions as well that I can't post to YouTube, links are in the description to my Patreon, that I react to many different things again that can't come onto YouTube. But we're going to check this out and see what this plane can do and to see how it came to be what it is now.
I've never flown an aeroplane like this where you can control the motion of the aeroplane so precisely.
I'm not sure we've even scratched the surface yet of what this airplane, when it's operating with other F-35s, is going to be able to do.
The F-35B is arguably the most advanced plane ever made.
Okay.
A jack of all trades. A stealth fighter plane, combining and improving on the capabilities of the F-16, AV-8B Harrier, and the B-2. A highly maneuverable fighter plane, capable of attacking both airborne and ground-based targets. A stealth fighter taking the lessons learned from Lockheed's previous ventures into stealth with the F-22 Raptor and the F-117.
See, this is the craziest one I've ever seen, man. It's just, it doesn't look real. It looks so sharp. It just doesn't look like it's a plane, but it's just crazy.
A plane fitted with the most advanced sensors and computer systems, sharing information almost instantly with allies without compromising stealth, and presenting the information directly on a heads-up display on the pilot's helmet visor, giving unparalleled situational awareness, allowing a flight of F-35s to effectively fight as a hive mind. Perhaps most boldly of all, the F-35B is capable of transitioning from horizontal to vertical flight with a push of a button.
So this can do the vertical flight as well.
Directional thrust and a massive vertical turbofan engine hidden within the plane's body, making it possible to land like a helicopter on the relatively small amphibious assault ships of the US Marines. This is the insane engineering of the F-35B.
Okay, here we go.
Fitting all these capabilities into a single airframe is an extremely difficult task. Designing for stealth demands careful molding of the exterior of the plane, dictating the design of crucial features, creating unavoidable trade-offs. There are a lot of misconceptions about stealth. The goal isn't to make the aircraft invisible. It will be detectable. The goal is to delay enemy detection for as long as possible. For bomber aircraft, it shrinks the range of the enemy's radar stations, potentially opening gaps in radar defenses and allowing the aircraft to slip through undetected. For fighter aircraft, it provides a critical advantage: detect your enemy before they detect you. To gain these advantages, we need to make it harder for the radar receiver to decipher whether the return signal is just background noise or an enemy aircraft. To do that, we need to minimize the strength of the return signal. There are several mechanisms for a radar wave to be reflected. The most significant and most obvious way is through spectral return, otherwise known as regular reflection, like a mirror, where the angle of reflection equals the angle of incidence. We want to avoid large, flat surfaces that could reflect straight back to the radar receiver. corner reflectors where two surfaces are set at a 90-degree angle to each other need to be avoided at all costs. Tailplanes consisting of the vertical and horizontal stabilizer are the perfect surfaces to create a corner reflector, allowing radar to bounce off both surfaces and return right back in the direction it came.
What?
The best way to avoid this is to remove the tail completely,
I didn't even think that was a thing with radar. That's crazy. What the hell?
in the direction it came. The best way to avoid this is to remove the tail completely, like the B2, but this impacts maneuverability greatly. Instead, we can replace both the horizontal and vertical stabilizer with a V-tail, as seen on the F-117 Nighthawk. The V-tail can act as both a rudder and an elevator, and we can see how by examining the resultant force generated when the control surfaces are actuated to different positions. We can actuate them in opposite directions to generate a horizontal resultant force, providing yaw control as a vertical rudder would. Or we can deflect them in the same direction to provide pitch control as a horizontal elevator would. This configuration is sometimes used for unique looking aircraft like the Cirrus SF-50, allowing it to mount a single tiny jet engine on top of the fuselage.
What the hell is this? I guess this isn't a military one. This just looks like the least military related aircraft possible, but it still looks pretty funky.
With its exhaust directed straight through the V-tail. A private jet so tiny and lightweight that it can deploy a parachute to rescue itself in emergencies. Having rudder and elevator controls linked to a single mechanism like this is not ideal. Fighter jets like the F-35 and the F-22 need superior control authority, and that is a function of control surface area. The larger the elevator, the larger the pitch control. If a control surface is working a double role, where rudder and elevator action is needed at the same time, it reduces the control authority. So, both planes also feature large elevators, offset by a distance and angled to prevent corner reflections.
Wow.
We can see many more trade-offs in design by comparing the F-117 and the F-35 in the quest to fulfill both stealth and fighter requirements. Both the F-117 and B-2 have their engine air intakes mounted on the upper surface of the plane, which prevents ground-based radar from bouncing around inside the intake and back to the receiver, and helps reduce infrared heat signatures. However, for a plane expected to make high angle of attack maneuvers in life and death situations,
What the fuck? Look at the ease that it just turned like that. How does my man just like not? He just doesn't like. For me, I'm thinking, how are you not passing out from this? But like, is it because when you're in the plane, it stops that sort of sensation? Or are these people so trained for it they just don't pass out in situations like this when they go at these speeds or do these spinny things? Like, what the hell?
death situations, this isn't a design you would want to include. While performing a maneuver like this, the air intake will receive lower pressure air, which will lower performance right when performance is needed most. Air intakes located underneath the aircraft, like the F-16, will cause too much radar return. So, twin intakes located on either side of the fuselage are instead chosen. These air intakes have some clever aerodynamic features too. This seemingly innocuous bump plays an important role. This is aeronautical engineering epitomized. Every seemingly insignificant design feature has a purpose. Mounting engine intakes along the body of an aircraft comes with some issues that pylon-mounted engines avoid. As air travels along the length of the body, air begins to form a layer of slow-moving, turbulent air called a boundary layer. If this air is allowed to enter the engine, it not only lowers performance, but it can also damage the engine. As the turbine rotates, it will pass through the slow boundary air on one side and then fast stream free air on the other. This means the force on the turbine blade changes for each and every rotation, causing cyclical bending, a recipe for fatigue failure. Planes like the F-16 feature a boundary layer diverter that separates the inlet from the fuselage with a small gap. But this design increases radar cross-section and increases drag. Later variants of the F-16 tested the DSI, the divertless supersonic inlet, essentially a large bump that creates a region of compression that pushes the boundary layer air away from the inlet, while also scattering incoming radar and lowering drag. The test flight demonstrated that it could meet performance requirements, ushering in its introduction to the F-35. The final product reduces weight by 30% and lowers production and maintenance costs. Moving down the plane, we can see other hints of stealth design. Long sharp edges are the enemy of stealth. Sharp edges causes radar waves to scatter in all directions.
You always see these sharp looking aircrafts. I didn't realize it was for the benefit of, I just assumed it made them quicker, but in situations like this, it's also helping them avoid detection from radar, which I didn't clock. But that's also another reason why they look cool like this, but it also helps them so much more.
Can even travel along the length of a surface in the form of a traveling wave and then scatter upon reaching the trailing edge. The strength of that return signal can be reduced with a few clever techniques. The strength of the signal will depend on the length of the edge, so the first technique is to reduce the edge length with serration. You can see this technique implemented very clearly on the trailing edge of the B-2. However, it's less obvious where it's used for the F-35, until you start looking at all the access hatches hidden around the aircraft. Every single unavoidable surface gap on the aircraft has a serrated edge. This hatch opens to reveal a telescoping ladder to allow pilots to climb in and out of the aircraft.
What?
These open to reveal the landing gear. These are the internal weapons bay, essential for keeping the radar reflecting missiles hidden from view. And these smaller hatches are flare dispenser doors. Flares are effective decoys for heat-seeking missiles, but they do nothing to prevent radar-guided missiles. In the face of radar-guided missile proliferation and continued growing sophistication in the technology, a new decoy system was developed. This new technology is released from this panel. When needed, this access door opens and a transmitter begins to reel out to a safe distance behind the plane. It has 3 levels of countermeasures to protect the F-35 from attack. First, it actively jams missiles while they attempt to lock onto their target, by emitting jamming signals which the onboard computer computes and delivers to the emitter through the fiber optic tow line. If the radar manages to obtain a lock, it then begins to attempt to break the lock, disrupting the tracking algorithms guiding the missile towards its target. Finally, if all is lost and the missile is bearing down on the aircraft, the emitter begins to simulate the aircraft's radar signature, drawing the missile toward it as a decoy.
What?
These serrated hatches hide critical components of the F-35, but more can be done to
Oh, that is crazy. That is mental. How are they able to even create these types of things?
reduce edge scattering in these locations. You may notice that the color around these edges is different to the rest of the plane. This is because the edges are treated with a special radar scattering tape. In the same way traveling waves scatter when they meet an edge discontinuity, they will scatter when traveling over a change in conductivity. The F-35 uses this to its advantage to scatter waves over a longer distance, reducing the return signal by spreading it out. The tape has a conductivity gradient, gradually decreasing its electrical conductivity, causing radar waves to scatter at each interval, slowly decreasing the intensity of the surface wave before it reaches the edge where it would have released one large return if the tape was not present. The surface of the plane itself is also composed of a specialized radar absorbing material. In 2010, Lockheed Martin filed this patent for a carbon nanotube infused composite material that can absorb radar waves from 0.1 MHz through to 60 GHz. This is an incredibly wide range of frequencies, notably covering the frequencies Russian surface-to-air missiles like the advanced S-400 system uses. The effect traveling surface waves have on stealth design can be seen elsewhere. You would imagine a cylinder would be a great way to scatter radar in all directions, lowering the strength of the return signal. But if a radar wave comes in tangentially to a cylinder, and the wavelength is at least 1/10 the cylinder's circumference, the wave can actually travel around the outside of the cylinder and travel straight back to the receiver. This is likely why the F-35 features a sharp edge breaking up the circular nose cone. Where the F-16 has a nearly perfect circular nose cone, the F-35 features a ridge. The largest hatch on the plane is strangely not serrated, and this is for good reason. This hatch hides the powerful lift fan within. The airflow in and out of this lift fan needs careful consideration. The lift fan is essentially a tiny helicopter, capable of generating 85 kilonewtons of vertical thrust, and in doing so creates a low pressure zone above the plane, violently sucking air into the aircraft at a 90-degree angle. This air has to travel over the hood to reach the inlet, and thus the hood needs to allow air to smoothly pass over it without creating too much turbulent flow, which would lower the performance of the lift fan. This is why the inlet door is not serrated, as the sharp edges would cause distortions in the flow.
That's crazy. Again, aerodynamics, all this stuff. I didn't realize it. These little things would affect the performance of the fan. Like, obviously, I never even thought about this before, but just the idea of it, the shape of this coming up can affect that. That every little detail has to be perfect. It's crazy how they can manage to find all these things, and then as a whole, they make this insane creation, which seems to be able to do it all. But yeah, I did not realize the details that would have to go into the, like, they just look insane. They look cool. They look like they can, I don't know, just cause absolute havoc if you're fighting against it. But then you've got these little in-depth details about everything that it can do, and it's just even crazier when you realize what's actually happening when they're creating these things, building them, and then flying them.
This HUD alone went through several design iterations to optimize the airflow flowing over it. The demonstration X-35 aircraft had 2 doors opening towards the side of the aircraft, but this was changed for the final aircraft in favor of a rear hinged door. This helps funnel air into the engine and improves pressure recovery on short takeoffs where the F-35B does not take off vertically, instead using the lift fan and directional thrust of the rear nozzle to take off on extremely short runways.
Wow.
The way this aircraft transforms to perform vertical landing and short takeoffs is astounding. It's the closest thing to a transformer we have ever created.
Literally, what the hell? This is baffling me. What the fuck? Look how it takes off. It is literally like transforming into a different form of travel. Like,
is
what?
Astounding. It's the closest thing to a transformer we have ever created.
Wow.
When the time comes, a clutch linking the extended drive shaft of the F-35's engine begins to transfer 29,000 horsepower to the bevel gear of the lift fan, spinning the contra-rotating lift fan blades. Simultaneously, gears begin to rotate in the rear exhaust nozzle. The mechanics of this nozzle are another wonder to behold. Called the 3-bearing swivel nozzle, it is composed of 3 airtight segments cut at angles relative to one another. We can change the shape of the nozzle by rotating these angled pieces.
It's like someone clenching their arsehole. Oh, mate. So you look at this stuff, right, and I guess, like, let's say 50 years ago, they would have created these aircrafts that back then they would have been like people would have looked at it and they'd be like, how are they doing this? And then you've got this now, and I'm looking at this and I'm like, how can you even better what's happening with this? This seems like it's got everything that's possible, and there's nothing else that could be added to this and all this stuff. But 50 years time, this will probably be seen as like, this probably won't even be in use anymore. But then that's when I come to the topic of, do you think there's going to be a point where you can't advance the technology for anything? But when we're speaking about this, about we can't advance the technologies for aircraft and stuff, because surely there's going to be a limit and there's going to be a point. And I'm looking at this and I'm like, where's the improvement here? But they're going to find it, and it's just crazy to me. And also seeing this, it makes sense as to why they're so costly, because they got all these crazy things built into them. It's mental.
Separately, these 3 pieces rotate together to smoothly transition thrust downwards, but it's easier to understand how it works by seeing what happens when we rotate segments individually. Rotating the central piece can take the nozzle from 0 degrees down to 45 degrees. This position is used for short takeoffs, splitting the engine's power between thrust and lift. This mode is as impressive as the vertical takeoffs, allowing the plane to operate from shorter amphibious assault ships like the USS Mackinac Island, a ship just 258 meters long. Its minimum takeoff distance decreases even further with the aid of a ski jump, a ramp that has been added to smaller amphibious assault ships.
What?
Watching the F-35 take off over such short distances is incredible. In this clip, we can see the rear nozzle quickly adjusting its angle of thrust in sync with the rear elevators to adjust the pitch of the plane to ensure a safe takeoff. For a vertical landing, the final nozzle segment can rotate to provide the full 90-degree turn. The first nozzle segment can rotate to move the nozzle from side to side, but here it's needed to ensure that thrust doesn't move sideways as the nozzle transitions. As we saw, when we rotate the segments individually, they move in an arc that would cause the F-35 to spin out of control.
Wow.
This mechanism also allows the F-35 to smoothly transition from cruise to vertical flight and from vertical flight to cruise when needed. There are additional control mechanisms to ensure this precarious balancing act does not go wrong. Bleed air from the main engine bypass is siphoned to 2 roll nozzles located on each wing, providing thrust far away from the plane's center of pressure to control roll. There are also guide vanes located underneath the lift fan. These can adjust the outlet area to adjust the performance of the lift fan, but can also control the thrust of the lift fan from 5 degrees forward to 42 degrees backwards. With computer-assisted control of these control mechanisms, the F-35 is remarkably stable compared to its predecessor, the AV-8B Harrier, allowing the single engine of the F-35 to hover on 2 columns of air. To do this, the F-35's engine, the F-135, developed from the F-119 engine of the F-22 Raptor, had to be incredibly powerful. The F-22 Raptor is a twin-engined fighter, giving it plenty of excess power to pull off incredible maneuvers.
What the fuck? Wait, what is this? Is this the... What are these waves? Is it the speed? Because it's going so quick, or is it the sound?
Fighter, giving it plenty of excess power to pull off incredible maneuvers.
What
the F-35 only has one engine, and needs to squeeze out all the power it can get to perform a vertical landing. Where the F-22's engine can generate 156 kilonewtons of thrust, the F-35's can generate 191. The F-35's engine has a much larger fan and bypass ducting, giving it twice the bypass ratio of its F-22 counterpart, providing the F-35 with a more efficient engine for cruise, but also a higher mass flow rate for higher thrust. However, this does come with some drawbacks. Air that travels around the engine core completely avoids the combustion chamber, and thus misses out on the acceleration generated there, reducing the exhaust velocity. This reduces the top speed of the plane. The max speed of the F-35 is 1.6 Mach, and while it's the first plane capable of vertical flight and supersonic flight, the F-22 can fly at 2.2 Mach. The F-35 was optimized for loiter time, not speed. However, all that extra weight needed for vertical takeoff seriously hampers that ideology. The lift fan module weighs 1.2 tons, weight that does nothing in normal flight and requires more fuel to carry. And to make matters worse, that space is used for internal fuel tanks for its variants. Making the lift fan as light as possible was pertinent to making the F-35B viable in the battlefield. The fact it only weighs 1.2 tons is astounding. It contains 2 counter-rotating titanium blisks. Blisk meaning the blades and disc are all one single piece, instead of the traditional alternative of creating a disc and attaching blades through dovetail connections. This improves efficiency and eliminates a potential site of failure in the connection. This is an astounding feat of manufacturing, and the first stage fan takes it even further. The first stage blades are hollow to save weight. Where the F-35B truly comes into its own, however, is in its modern suite of sensors and computers, all feeding into this: the heads-up display incorporated into the pilot's helmet.
What?
Traditional heads-up displays, like those of the F-16, are incorporated into a panel in the cockpit, a panel which the pilot can't see while scanning their environment. Situational awareness is everything in the heat of combat, and this helmet does everything it can to keep the pilot informed, even giving them X-ray vision and night vision.
Oh my god, what the fuck? Jeez, what is going on?
Information from a suite of sensors around the plane feed into a central computer, where it is processed and displayed through a projector inside the helmet. Inside this transparent faceted box underneath the aircraft is a suite of sensors, but those are not your typical windows. These windows are made from a notoriously expensive gemstone, sapphire. One of the few materials that is both hard and durable, but also transparent to a broad range of electromagnetic wavelengths, from ultraviolet to infrared. However, the radar antenna hidden inside the nose of the F-35 is the most important part of this electronic system. This is a scanned array radar that works very differently to traditional mechanical radar. Phased array antennas have hundreds of tiny antennas. We can see metal plates set in rows in the F-35 phased array antenna. The metal plates have slots cut into them, and each and every one of these slots is an antenna, 1,600 in total. This allows the phased array antenna to steer its radar using constructive and destructive interference. If two antennae release two radar waves at the exact same time with their peaks and troughs lined up, it will result in constructive interference, increasing the amplitude of the radio wave. However, if the radio waves are set 180 degrees out of phase, matching the peaks to troughs, it will result in complete destructive interference, cancelling out the wave completely. This is how noise-cancelling earphones work. They listen to the background noise and then release a cancelling sound wave to create silence.
So my AirPods, why they baffle me, when I first used them, I was like, wait, what? This is the craziest thing I've ever wore. It's the same concept. Damn. Well, who knew I was that close to flying a F-35B? I'm joking, but...
Phased array antennae use this phenomenon to steer the radio waves, preventing the radar from becoming a giant beacon, leading enemies straight to it. Traditional phased array antennas are passive, meaning every antenna in the array is driven by a single transmitter and receiver. This would mean it can only point in one direction, and if it encountered two enemy planes flying side by side and they split up, the passive phased array antenna would no longer be able to track both of them. However, the F-35's phased array antenna is an active phased array, meaning each and every one of these antennae is an individually driven transmitter and receiver, meaning the F-35 can track multiple targets at once with zero moving parts.
Oh my days.
The nose cones hiding these antennae need to be transparent to radar waves, and are usually made from glass fiber composites as a result. This transparency causes issues for the plane's radar return signature, as an antenna like this will reflect signals. This was a much bigger issue for mechanical radar dishes that needed to point at the enemy to keep track of them. The phased array can point towards multiple targets while staying in a single position, and this is why it is pointed skywards, to bounce incoming radar to space. The phased array antenna also acts as the plane's communication antenna, and this is critical to the F-35's battle doctrine. The F-35 excels in battle because of its networking abilities, relaying information between its squadron. This is a huge amount of data to transfer between aircraft and allies on the surface, and requires a high data transfer speed. However, communication comes with one glaring problem. It announces your presence to anyone listening. It is vital that stealth planes can communicate with each other securely, and the active phased array antenna facilitates this. The F-35 uses the latest data link system, MADL, improving on the experiences learned with the F-22, allowing the F-35 to quickly share data securely from individual F-35s and ground-based systems. This information is then sorted by the computer and presented to the pilot in their heads-up display right in front of their eyes.
As crazy as all of this is, this like the training you must have to go through as a pilot to control all these things, to like what he's now explaining here. Just there's so many different aspects. Like the training I can't imagine how long you have to train for it and all that stuff, but it must take months, if not years. And you've obviously already have to have flown other planes and obviously have to be a pilot for starters. But all these different things, it's crazy how there's just so much you have to focus on. And as crazy as the technology is for this plane, the pilots are just as crazy. Like, it's just as crazy how they can manage to control all these things and all this stuff,
giving them unparalleled to the pilot in their heads-up display right in front of their eyes, giving them unparalleled situational awareness. There is no need to communicate.
But I say that, I guess it makes it easier for them, me saying that, but all this stuff to focus on, but it does make their job so much easier. But there's just so much more to focus on.
With their wing mates, if there is an adversary underneath them, the planes communicate and feed that data right into the helmet, allowing the pilot to look underneath the plane and see the location of the adversary themselves.
What?
This is the true strength of the F-35B. It is a networked hive-mind stealth fighter, capable of taking off from a ship a fraction of the size of an aircraft carrier, and returning while hovering in the sky like a helicopter. It's one of the most remarkable pieces of military technology ever created. The F-35 has borrowed many lessons learned from planes like the F-117 Nighthawk and B-2, planes that we have not made documentaries about yet, but our friends over at Mustard have. Their B-2 documentary is 20...
Oh, is this his ad? Come on, man. He's getting his money. I know this is obviously not possible, but I'm thinking in my head, imagine if there was just one of these F-35Bs for the US, just one of these, had all the capabilities and it could fly, it could just do everything it can do now. In World War II, let's just say for Pearl Harbor, just say there was one of, this might sound so stupid, but one of these against all the Japanese aircraft that they had, but they have the same as they had during World War II. How do you reckon that would go? Do you reckon they would even be able to take this out? Or there's just so much technology in this. This one plane would just take out the entire crew, like the entire crew or group of the Japanese aircraft. Like I know that's just a stupid question, but honestly, just thinking about it, I think it's at that point now where it would just literally it'd be a breeze. There would not even be any effect to it. But maybe that's a bit too eager, but you know what? It's crazy just to see this stuff and how it's going to be in 30, 40 years' time. I don't know, but how you can better this, it's beyond me. But yeah, these reactions, the insane engineering. Let me just see. Have I done more of these? The insane... I think oh, it spelled it wrong. I think I have. I don't know which ones. The Javelin, done the reaction to the insane of the Javelin. The A10 Warthog and the SR-71 Blackbird. So these are the reactions that I've done to this channel before, if you'd want to see that. But yeah, you just have to search this in the search bar. But yeah, man, this is insane. This is absolutely insane. And I mean, yeah, hopefully you enjoyed this reaction. If you want more reactions to this channel, I'm down for it because it's really well put together. And yeah, the channel is just very interesting and really informative as well for someone who's got a simple mind like me. But yeah, hopefully you enjoyed this reaction, and until next time, like, subscribe, peace.